if the dimension of transmission line match this, the waveform length lambda. We use lambda to express the waveform length. Waveform length. How to calculate this lambda? Lambda equal to the speed c over the f frequency. We know the power system is 3 kilometer per second. But the frequency is 50 hertz. So it will equal to 6,000 kilometer. But for this circuit is 1,500 kilometer. So we can compare them. They are not much less. So if a circuit less than 100 kilometer, so we don't care about. We treat it as a number circuit. But if a circuit, because the waveform length is 6,000 kilometer, if 100 kilometer, much less. But if a circuit is 1,000 kilometer, we must treat it as a distributed circuit. Because the 1,000 kilometer, the 6,000 kilometer, we can compare them. It's not much less. So this is the difference between the number and the distributed circuit. We compare the length of the circuit with the length of the waveform. The length of the waveform calculated from this function. It depends on the frequency. So for the power system, the waveform length is 6,000 kilometers. But for the communication system, because the frequency is very high, maybe the 1 G hertz. 1 G means 10 lambda. So the lambda will be 0.3 meters. So for the communication system, the waveform is much less. So for a common circuit, maybe your cell phone is 0.01 meters. That means 10 meters. So we can compare them. This 30, we can compare them. So it's 30 cm. But your cell phone is 10 cm. We can compare. So for the communication system, your cell phone is a distributed system. But for the power system, your cell phone is a number circuit. Do you understand? For your cell phone, for example, is 10 cm length. For the power system, is number circuit. But for the high frequency communication system is distributed circuit. So the concept for the concept number and the distribute depend on the frequency, on the circuit length, and the lambda. Compare this, and we can define it from the other point of view. At any time t, flow into one port current is the same flow out of other ports. We call as number circuit, or it will be called as a distributed circuit. For the number circuit, we use common ordinary differential equation. That means the equation, the u and I, is only the variable function of time t. But for the distributed circuit, the u and I will be x, t. There will be two variables. So how to use the partial differential equation? What this means, flow into will equal to flow out. Because this point, this current I flow into, not equal to this flow out. This IA, this IB, not equal. They are not equal. So the KCL is not conform. The KCL not conform because the waveform transfer in the time to transfer. So the KCL and the KVL only conform to the number cycle, but the distributed cycle is not conform. Okay, the second concept, time invariant and time variant. If what current ut it was some one solution for the component, this time t is a constant, any constant. If the u delay time t and I delay time t is also a solution, we call this component as time invariant component. This u and I is vector. This is for multiple network. This is for component. So these two definitions are the same. This is for common one-port component. This is for n-port network. So this u and I is a vector. This u and y is a common variable. For the time invariant circuit, the circuit contains only independent source and time invariant component. For example, proof psi equal to LT IT is a time variable one-port network. The LT change with time, but not change with voltage and current. We assume U1, I1 is one solution for this component. This is a new component. We know this psi equal to LT IT. At first, we assume this U1, this I1. And assume I2T is I1 delay. So we can calculate the psi 1 and psi 2. Psi 1 LT I1T, psi 2 LT I2T. But I2T is a delay of the I1T. I2T delay of I1T. The U1T is a psi 1 differential. This is psi 1 differential. The U2T is psi 2 differential. This is psi 2 differential. And then we can find DLT dt I2T, LT di2 dt. So this I2T is I1 delay. I2T I1 delay. This U2T expression. So this U2 expression is not equal to the U1T delay T, because the U1T delay, if the U1T delay, U1T delay, U12 delay, this U12 delay will equal to this expression, any T will delay, D LT minus T dt mod I1T minus T plus LT minus T d I1T minus T dt. So they're not equal. This expression not equal to this expression. So these components, we call these components time variant. The problem comes from the L. Come from this L contain T. This L contain T. So the U1T delay, I1T delay is not a solution. Because I1T delay, the solution U2T not equal to the U1T delay. So this network, this component is a time-warrant network. If the LT is a constant L, we can assume U1 I1 and U2 I2. I2 is the I1 delay. This is what I1 plus I1 plus I2. U1 is d plus I1 dt equal to L di1 dt. U2 is d plus I2 dt equal to L di2 dt. This is only one part. This is only one part. Because I2 is the delay of the I1, so we can find this expression. This expression is just this expression delay t. So this means U1T is a delay, U2T is a delay of the U1T. So U1 I1T delay, U1T delay is also a solution. So this component is time invariant, one port network. So the conclusion is if RCL, I mean the parameter, this parameter. If this parameter R change with time t, the CL change with time t, so it will be time invariant component. If they are not change with time t, time invariant, so the component will be time invariant. So this is a common and a simple method to judge. So for a resist, if the resist is 10 ohm, it's time invariant. If resist is 10 ohm plus the T marked 0.01, so this will be time invariant. This time invariant, because this is a constant. For independent source, independent voltage source, UT. Blue, the U1 I1 is a solution. Assume the tau is a constant. The U1 T minus tau. This will be new source, the new voltage source. The original voltage source will not have such a solution. The original source is E sin omega t. The new source is E mod sin omega t minus tau. So they are not the same. So the AC source is time invariant component. AC source time invariant. So if we treat the independent source as a component, the DC source is time invariant, but AC source is time invariant. If we treat the source as stimulant, the total circuit will still be time invariant. For example, prove this circuit is time invariant, one port network, but the total circuit is time invariant. At first, we discuss the U and I relation. The U will equal to I multiplied 5 plus this source. Assume U1 I1 is solution. And assume the I2 is I1 delay. And the U2 5 mod I2 plus source. I2 is I1 delay. So this expression is not equal to this expression just delay. If this expression delay, it will be 5I t minus t and plus um sin omega t minus t. This is U1 delay. So the U2T not equal to the U1 delay. So this one port network is time invariant. One port network. It comes from the problem of the source, the AC source. If this is a DC source, if UST equal to UST equal to UM, so the circuit will be time invariant. they will be equal. If the UST is equal to UM is a constant, this will be equal. Theta will be equal. So question 2. Question 2. By any circuit analyzer method, we can get any response can express as this response, this source. For example, if we add a resistor here, this R2, this R1, this is the source. In this circuit, any response, maybe this U is a response, this I is a response, or this U is a response. Any response can be expressed by the linear consumption of the source. If the source have a delay, the response will have delay also. If this T delay T, this will delay T also. So for the total circuit, if we discuss the stimulate and the response relation, they are time invariant. But if we discuss the U and I relation, the port U and port I relation is time invariant. Okay, I will make a conclusion. Time invariant and time invariant if we discuss the multi-port network, for example, one-port network, UI. For the one-port network, when we discuss time invariant or time invariant, we are discuss the U and I relation. But if we discuss a total circuit, we always discuss the response and the stimulate. The stimulate is always the source, the power source, the independent power source relation. So when we discuss the circuit, if we discuss the multi-port network, so this related to the concept of the circuit and the network difference. One multi-port network, this is a circuit. Circuit is a whole part. For a circuit, it must add a resist other port outside. They can form a loop. It cannot be open. So this is a definition of the time invariant and time invariant for the port network, multiple network, or for the circuit. Okay, today's content is enough. So the class is over. Do you have any question? Okay, if no question, I will close the PowerPoint. I'll close the PowerPoint. Okay, for this chapter, it will be very abstract and a little difficult to understanding. Okay, see you.
See you.
Thank you, sir.